Welcome to Djam Academy. My name is Kimal Djam, and it is my delight to bring to you this very interesting lesson in two-dimensional motion. A typical example, or the most common example of an object moving in two dimensions is a projectile. Now, a projectile really is anything whose motion is under the control of gravity. Gravity is an attractive force that the earth exerts on any object on it. For example, if I throw this pen upwards, it falls back down because the earth attracts the pen with a gravitational force acting downwards. We simply call that gravity. And the motion of the pen is a two-dimensional motion. I'm going to show you how to analyze this type of motion using the principles of kinematics in two dimensions. So we have this is our x-axis and this is our y-axis, and we happen to throw a ball upwards, and that ball follows a parabolic path. This is the ball. So first of all, we're assuming that there is no wind and that there is no air resistance. In the absence of wind and air resistance, the only force that controls the motion of this ball is the gravitational pull of the earth, or simply gravity. And this force acts vertically downwards. So this is the force of gravity. It acts vertically downwards. Now it has two important implications that I would like for you to know. But first, understand this. Newton's second law tells us that the resultant force, or the sum of all the forces acting on an object, is equal to the mass of that object multiplied by its acceleration. This equation can be broken down into two. This implies that the sum of forces in the x direction is equal to the mass of the object times the acceleration in the x direction, and the sum of forces in the y direction is equal to m times the acceleration in the y direction. Now, this is what we know. We know that the sum of forces in the x direction is 0. There is no force acting along the x direction. Let me say that again. There is no force acting along the x direction. So this means that max is equal to 0, which implies that the acceleration in the x direction is 0. Great. Similarly, the sum of forces in the y direction is equal to may, which means that may is equal to mg. Why? Because the force of gravity is just the mass of the object times the acceleration due to gravity. The masses can cancel, and this would mean that ay is equal to g. In other words, the magnitude of the acceleration in the y direction is equal to the acceleration due to gravity. So what does this mean? So what does this all imply? It means one or two things. So we have shown that the acceleration in the x direction is 0, and the acceleration in the y direction is constant, which is simply the acceleration due to gravity. What does this mean? If the acceleration in the x direction is 0, it means that the velocity in the x direction remains constant. In other words, the horizontal motion is uniform motion with a constant velocity. Now, the acceleration in the y direction is constant. What does this imply? It implies that the vertical motion is uniformly accelerated motion with a constant acceleration. Now, the third thing that you need to keep in mind is the fact that gravity only acts vertically downwards simply implies that gravity only affects the vertical motion and does not influence the horizontal motion. Now, one of the tricks that we will use in analyzing projectile motion is the fact that the horizontal motion is completely independent of the vertical motion. And I have just proven that the horizontal motion is motion with a constant velocity, while the vertical motion is motion with a constant acceleration. Now, in the next step that I will show you, it is imperative that we separate the horizontal motion from the vertical motion, because the horizontal motion is always and completely independent of the vertical motion, as long as the only force that governs the motion of the object is the acceleration, is the force of gravity or the gravitational pull of the earth. So let's roll. So I'm going to do this. We have this is the horizontal motion. And this will be the vertical motion. Right here, we'll write down the equations of motion for horizontal motion. I'll write down the kinematics equations of motion for the vertical motion. The very first thing that you need to take note is the fact that AX is 0 and AY is just equal to negative G. That is the very first thing that you need to take note of. Now, it is crucial because AX is 0, it means that VX So the very next step that we will take is to look at the horizontal motion and the vertical motion separately. One, we know that AX is equal to 0. And 2, we know that AY is equal to negative G. We are taking the upward direction to be positive and the downward direction to be negative. Because the acceleration due to gravity is directed downwards, it bears a negative sign at all times. So Vx will be equal to Vox plus AXT. Similarly, Vy is equal to VOY plus AYT. This right here will be equal to VOY plus 0. This right here will be equal to VOY minus GT. So this means that Vx is equal to Vox. This is not surprising because the horizontal acceleration is 0. It basically means that the velocity in the horizontal direction will remain constant. And right here, Vy is equal to Voy minus GT. What this tells you is that the vertical velocity actually decreases to 0 at maximum height and then increases uniformly. We will draw this later in a graph. Now, similarly, x will be equal to x naught plus voxt plus 1/2 ax t squared. Y will be equal to y naught plus voyt plus 1/2 ayt squared. Now, this is 0. This would mean that x is equal to x naught plus voxt. This describes how the position of the particle changes in the horizontal direction. And similarly, we will have here y equal to y naught plus voyt minus 1/2 gt squared. This tells us how the vertical position changes with respect to time. So if we draw the graphs, this is t, this is a, it's gonna be 0. This is t in seconds. This is ay, this is ax. It's gonna be right here, negative g. So if we draw the graph of t, vx, it's just gonna be constant. But if we do the graph for, this is t, time is always in the horizontal axis. This is vy. Notice something. When t is equal to 0, vy is equal to v naught y. So it decreases. So it starts somewhere there. It starts somewhere here and decreases like that. This is voy. Keep in mind that at this particular point x, vy is equal to 0, and this occurs at maximum height. And that occurs at maximum height. Also, it is important for you to note that this area, A1 is equal to A2. And lastly, if we draw the graph for x, this is t, this is x. If you look at this equation, x is equal to x naught plus voxt, which means that it starts somewhere. This is x naught, and it goes up like that. But if you draw the graph, t, this is y, this is y naught, it goes up like that. So you can clearly compare the graphs for the horizontal motion and the graphs for the vertical motion. They are very beautiful, but they are fundamentally very different. Now, the next thing that I would like for us to do will be to look at the equation of motion or the equation of trajectory. Now, the equation of motion is y expressed as a function of x. It is not y expressed as a function of t. The equation of path or the equation of trajectory is y expressed as a function of x. Now, we're going to make some fundamental assumption here that we initially launch the particle. This is y, and this is x, and this is the origin. That we initially launch the particle essentially at the origin, right here, all right, now if that is the case, the initial velocity is v naught and the launch angle is theta. Watch carefully. It means that we can actually resolve the initial velocity into its initial horizontal component and its initial vertical component. This is Vox and this is Voy. Now, at any time t, for example, at this juncture, the speed or the velocity v is in that direction. So we can resolve this as Vx and we can resolve this as Vy. Similarly, right here, the velocity is pointing in this direction, v. So, and the speed is actually just in one direction because the speed Vy at the maximum point is equal to 0. Let's call this distance here the maximum height, y max, and the range, r, is the maximum horizontal distance from where the particle is launched. So how do we proceed? What do we know? We know that x naught is equal to y naught, which is equal to 0. And if that is the case, we therefore can say that x will be equal to v ox t, which would mean that t is equal to x divided by v ox. Here we have expressed the time in terms of x. Similarly, y is equal to v oy t minus 1/2 g t squared. This is the equation that we did write down a little while ago. Now, here's the thing. We can then substitute the value for x from the first equation into the second equation. If we do that, we will have y equal to voy bracket x divided by vox minus 1/2 g bracket x divided by vox all squared. And if you simplify the equation, y will be equal to voy divided by vox x minus g x squared divided by 2 vox all squared. Right here is the equation of path. This is the equation of path of the projectile or trajectory. And clearly, you can observe that the equation of path is a parabola. So generally, the equation of path of a projectile is a parabola. Now we are going to look at some instances, some particular instances, and see how we can apply them in this particular case. So let's look at the case but first, before we move on, I would like for you to observe something. This is the maximum height. At maximum height, Vy is equal to 0. That is very important. Why? Because Vy is equal to Voy minus Gt. And this is equal to 0 at maximum height. This means that T max is equal to VOY all divided by G. This is the time to reach maximum height. This is the time to reach maximum height. Now, if you look at the path of a projectile, it is highly symmetrical. Let me say that again. The path of a projectile is highly symmetrical. That means that the time it takes to reach maximum height, as long as the projectile is launched on a flat horizontal surface, is equal to the time for which the projectile hits the ground again. If that is the case, it means that the total time of flight, t, is equal to 2 multiplied by the time to reach maximum height, which is just going to be equal to 2v0 all divided by g. This defines the total time of flight. Very important, it defines the total time of flight. Now, the horizontal range, R, is defined as the maximum horizontal distance. The horizontal range is defined as the maximum horizontal distance. And if that is true, then R is, which is equal to X max, is going to be equal to VOX multiplied by the time of flight. This means that the range R is equal to VOX multiplied by 2VOY divided by G. Therefore, the range R is equal to 2VOX multiplied by VOY divided by G. This defines the horizontal range of the projectile. Now, you don't necessarily have to memorize these equations, but it is important you know how to derive this equation, especially for an AP test.